So we took notes yesterday on basic notes on quadrilaterals, and one of the ways that will help you understand classifying quadrilaterals is to think about a hierarchy. So overall, the main category is just the name quadrilaterals, any four-sided figure, and when it says definition, that's all you need, four-sided figure. So every one of the shapes that we will be dealing with will at least be a quadrilateral. So when you're classifying, you can always put that if you can't figure out any other specifics. Okay, and then within that, we had a couple special ones we made the pictures of yesterday. So you have a kite, and the key characteristics, two adjacent sides congruent. Diagonals are perpendicular. If you don't want to write perpendicular, use your symbol. Diagonals bisect angles. We won't use this one very much, but every once in a while that may be a characteristic. And then there's a formula for the area of a kite. 1/2 diagonal 1 times diagonal 2. And we will get to area of each of these individual shapes later on. This is sort of the intro. You might just want to have a quick visual, including especially the congruent consecutive. So these are the adjacent congruent sides, and then the diagonals perpendicular. Another category that are the ones that you probably didn't cover as much when you're a little kid in detail, and that would be the trapezoids. You knew what they were, but only one pair of parallel sides. Exactly one pair. So if you have two pairs, it goes into a different category. Area of a trapezoid, you add the bases, divide by 2, which means you're taking the average of the bases and multiplying times the height. Again, we'll do some of the more specific area problems. So under that category of trapezoid is isosceles trapezoid. And isosceles trapezoids are trapezoids, so they have everything that a trapezoid has, plus they have congruent sides. The non-parallel sides are congruent. So you don't need to write number 1 again. It's same, because we're in the same family. And then the non-parallel sides congruent. So if you're drawing a quick sketch, these are the parallel sides, these are the non-parallel sides, and they are congruent. Another feature is the base angles are congruent, and you can call usually the bigger side is what we call the base down there, but either side is a base. You notice in the formula there's a base 1 and base 2. These angles are congruent, these angles are congruent, and diagonals are congruent. So in a kite, the diagonals kind of make that base shape of your kite in an isosceles trapezoid. So those two are congruent. It is not true for a regular trapezoid. I didn't draw a picture up there, but a regular trapezoid, because one of the bases is bigger than the other one, it's not true. And the area formula is the same. So if you're in the same family, you share some of the same characteristics, but you don't share all the characteristics. Okay, so that's one. This is no parallel sides, one parallel side. Now, two sets of parallel sides. parallelogram, and it's a quad with both opposite sides parallel. So we made a sketch earlier, but it's good to have it here with that picture. It's on the other side of this paper. So opposite sides are parallel. And if you want to abbreviate parallel, there's an abbreviation. Opposite sides are congruent. Opposite angles congruent. And adjacent angles sup. And the area equals the base times the height. So opposite sides is easy to see. When you make the shape, you can tell. Opposite angles, you can kind of tell when you look. So we're talking about the corners. They are congruent. Any two angles in a row are supplementary. So add these two, it's supplementary. Add these two, it's supplementary. Add these two, it's supplementary. Because you have all these parallel lines, you can go here plus here is 180. Here plus here is 180. Here plus here is 180. So that's a general parallelogram. Now, anything that falls underneath this category is also a parallelogram. So we have rectangle, rhombus, and the square. So rectangle, our key defining point is 4 right angles, because everything else is the same as a parallelogram. So same, 4 right angles. And the area of a rectangle is also the same, base times height. We'll do area a little more specifically later. This just helps to concentrate this all together. A rhombus has 4 equal sides. So opposite sides are parallel. So that part is still the same. Opposite angles are congruent, but all the sides are congruent. Important to note. And the diagonals are perpendicular. Area formula for a rhombus, 1/2 d1 times d2. You'll notice that is the same as the area formula for a kite. Sometimes people get the kite and the rhombus properties mixed up. Okay, so square. The square has all of these characteristics. We said if you add all of the rectangle stuff, which is 4 right angles, and add the 4 equal sides and the perpendicular diagonals, then you get a square. So 4 right angles, 4 congruent sides. That's your rhombus. That's your rectangle. Put them together, you get square. Area is a side squared, or a side times side.